Good afternoon, all of you all. I hope you are doing fine. So let's start with the next chapter or next topic, which was linear differential equation. If you remember, can someone confirm if you can see like and hear properly? One second, guys. Yeah. Good evening. Good evening. Yes. Chalo. Let's start. So we will now see linear differential equations. I hope you know that we covered homogeneous and equation reducible to homogeneous in the last lecture. So in this lecture, we will cover linear equations and equation reducible to linear. Let's see first how linear differential equation looks like. So as you all know, a linear differential equation is of this form: dy by dx plus py equals to q. dy by dx plus py equals to q. Got it? Where p and q are functions of x. P and q are functions of x. Good evening all. This is the form of linear differential equation. P and q should be functions of x only. We have one more form which we'll see afterwards, but let's see what is the solution of linear differential equation. I hope you know the solution, but let us see through how do we derive it. So basically, the linear differential equation, we multiplied the linear differential equation on both the sides with e raised to p dx. This is the solution. Now let's see how it came. So the given equation was this. We multiplied it with e raised to integration of p dx. So here, as you can see, we multiplied both the sides by e raised to integration p dx. Now, as you can clearly see, what will be our next step? The given format was derivative of y into e raised to integral p dx. If you can't see this format, this whole can be written as derivative of e raised to integral p dx into y. Then if we apply uv rule, u derivative of v plus v derivative of u, we will get this. So basically, we got d by dx of y into integration of p dx. So if now we integrate both the sides here, integration and derivative will get cancelled and this will remain as it is. And you all know we call this as integrating factor. We call this as integrating factor. Here it will get cancelled and we'll be left with this, which is our solution, where e raised to integral p dx is called integration factor. This one I am talking about is called integration factor. Chalo, note 2. What is note 2? This is the second type of differential equation where just the dependent and independent variables are getting interchanged. Here we have dx by dy. See the relation? It is exactly the opposite. Wherever we had y, now we have x. Here we had y, now we have x. Here p and q are functions of x. Here p and q are some functions of y. So it is exactly opposite, and therefore in the solution also we'll get exactly opposite. So the solution of this, if you remember, it was y into integrating factor is equals to integration of q into integrating factor dx. Now in this, just replace y by x. So we got this solution. See, x into integrating factor is equals to integration of q into integrating factor dy plus c. So the difference is this simple difference. It is what simple difference? Ki just replace y with x. So we get the solution of this. Let's see what is note 3. Note 3 is the solution of this. We got this right. And note 4 is just a summarized version. So this is all we have to learn in linear differential equation. Basically, these are the two formats. Now, it is not necessary that we'll get only in terms of y and x. Many a times they use r and theta, which are the polar coordinates. So when those sums come, we'll deal with them accordingly. Now let us focus on solving questions as we have completed the theory part. So let's say MCQs, and these are some basic MCQs which I think you should answer in the chat box. Got it? So here are the options. Come on, which option it is? 1, 2, 3 and 4. I'm waiting for your answers. Which option it is? Read the question. This is just to, you can say, revise, go through what we studied just now, 2 minutes earlier that we studied. So, which option it is, guys? We have to find integrating factor of this. Come on. Two students are present and they are Devan and Swati. Three. So, 3 e raised to p dy. Dy by dx plus py equals to q. So integrating factor will be e raised to integration p dx. P is a function of x. Here, p and q are functions of x. So if p and q are functions of x, then that means we have to integrate with respect to x. We cannot integrate p with respect to y. Got it? Next question. Right now? Okay. Chalo. Give me the answer. These are MCQs are just to check if you are paying attention or not of all the theory we covered. Now I want Swati to answer. Are you there, Swati? Chalo. What is the general solution? Again, p and q are functions of x. That means they should be integrated with respect to x. So, if we go according to this logic, this option and this option is gone. Because here integration is with respect to y. So that means only two options we have. It is second and third. Third one, superb. Y into integrating factor equals to q integrating factor dx plus c. Very good. Let's see the next. Chalo, this should be easy. P and Q are functions of y. So that means we have to integrate with respect to y. So e raised to integration p dy. Very good. Next, the last one. What is the general solution of this? Come on. If you remember the general solution of the first format, we just have to replace y with x. So if we replace y with x, we'll get the second format. So p and q are functions of y only. So that means second and third is gone. So that left us with first and fourth. What is the answer now? First and fourth? Fourth. Very good. Chalo. Now the basic warm-up questions are over. So let's focus on doing some interesting questions. Chalo. What will be this answer? First, compare it with dy by dx plus py is equals to q. So p is 1 upon x and q is 2x square. We have to find integrating factor is e raised to integration p dx. That means e raised to integration of 1 by x dx. Very good, you already gave the answer, e raised to ln x. And by property of log, we can say this is equals to x, which is option number 3. Superb. Next, solve this. Oh, huh. Same, what we will do, we'll just compare and write the solution. This is one step aage. So let me move here. Yeah. We can compare it with dy by dx plus p into y equals to q. So this is p. That means p equals to 2 by x and q equals to 2x square. Okay, so integrating factor will be equals to e raised to integration of 2 by x dx, which is e raised to 2 ln x. Now 2 will climb here, so I'll get e raised to ln x square. Again, by property of log, this will be equals to x square. Now what is the solution? The solution is y into integrating factor is equals to integration of q into integrating factor dx. So this is my integrating factor x square. So y into x square is equals to integration of q is 2x square. So 2x square into x square dx. So this leaves us with 2x raised to 4 dx. What is integration of x raised to 4? 2 into x raised to 5 upon 5. Superb. So 2x raised to 5 upon 5 plus c. So I got yx square. So if we cross multiply, denominator generally पसंद नहीं है अपने को. So I'll get 5x square y equals to 2x raised to 5 plus the c will become c dash. So this is my answer. Got it? Okay, Swati is live now. Till then, I think you were. Okay, fine. Chalo. Let's see the next question. This one. This is a good question. See if you can, like, if you want to do speed test, what is meant by speed test? Ki I solve first or you give me answer first. So we can do speed test also. Get your books and pens ready and we'll start now. So first, I need to divide by 1 plus x square. So I'll get dy by dx plus 2x upon 1 plus x square into y is equals to 4x square upon 1 plus x square. So this is p and this is q. So what is integrating factor? Integrating e raised to integration of 2x upon 1 plus x square dx. This is the format of f dash of x upon f of x. In such cases, what is the answer? It is e raised to ln 1 plus x square. Now, according to again property, my integrating factor will be 1 plus x square. Right? You are not done with the answer. I think I'll win this one. So, the solution will be y into integrating factor is equal to integration of q 4x square upon 1 plus x square into integrating factor dx. So this 1 plus x square will get cancelled. So I'll get y plus x square y is equals to 4x cube by 3 plus c. We can cross multiply, so I'll get 3y. I took y common again, I don't know why. But 1 plus x square is equals to 4x cube plus c dash. This is my answer. Sir, completed. You don't need to write the equation. I think it might be difficult for you all to write the equation, right? It's fine if you just say completed. Then you can cross-check the answer. Very good. Chalo, I need to improve. I'll skip some more steps then. Next question. Solve. This is also a good question. Let's start. First, I need to multiply with x. Correct? So I'll get dy over dx plus x e raised to x into y is equals to x into e raised to 1 minus x into e raised to x. So this is p and this is q. Correct? So my integrating factor will be e raised to integration x e raised to x dx. Now here you can use integration by parts. So by using integration by parts, I directly remember the answer. So I'll write it directly. If you don't remember, you can say, then we solve with integration by parts. It is simple. This is the first function. This is the second function. So I'll get x e raised to x, correct? Minus e raised to x. So this is my integrating factor. So what is my solution? Solution will be y into integrating factor is equals to integration of q x into e raised to x minus x e raised to x minus x into e raised to x into e raised to x e raised to x minus e raised to x dx. So if we look at the powers of exponential function, they'll get added. So what I'll be left with is integration of x e raised to x minus x e raised to x plus x e raised to x minus e raised to x. So this will all get cancelled and we'll be left with e raised to 0. What is e raised to 0? It is 1. So I'll get integration of x dx. On the left hand side, we have the same y into e raised to x minus 1. So we got a very simple answer. Y into e raised to x minus 1 is equals to x square by 2. So I'll cross multiply the 2 here plus c dash. This is my answer. See it, x square plus c, yeah. So I hope it is clear. This step was important here because the base is same, so power will get added, basic exponential. I hope you got this. Let's move on to the next. Yeah, this is a good question. I think you might have done this. Super. Let's see. Now, one of the thing like that I forgot, or let's say I did not want you to know till now, or I hope you know till now, कि question जब भी आएगा, when will question come, it will not be written कि हाँ solve by linear differential method. That we have to think on our own कि which method is applicable, either variable separable, homogeneous or linear. So how to think that is, if the question is on linear in y, that is the first format, dy by dx plus py equals to q. So there you will see only one y term and multiple x terms. What I'm trying to say is, let's write the formats here. Dy by dx plus py equals to q. And second was dx by dy plus px equals to q. Here, p and q are functions of x, means there are many x. And here y is alone. This P and Q are functions of Y and X is single. So whenever in a question we see either X is single or Y is single, then single means akela, means only one in mathematics. So then we can say it is linear in Y or linear in X. So here, if you see, if I try to write dy over dx, it will be 1 upon x plus y plus 1. So, as you can see, the power of x is also 1, power of y is also 1, but this format cannot be arranged, the first one. See clearly. So that means we have to arrange the second format. And to arrange the second format, we need dx upon dy. So if I get dx upon dy, it will be equal to reciprocal x plus y plus 1. Now you can see we can easily arrange this format. How? We can write it as dx over dy minus x is equals to y plus 1. Now if minus 1x, let me write. So if we compare now, this is P and this is Q. So now this format is changed into the second one. So my answer will also change accordingly. You got the answer? No. So now you can start with me. Let's start. What was the integrating factor? It was e raised to integration of P dy. All the x will change to y and vice versa. So here I'll get e raised to minus y. And what was the solution? X into integrating factor is equal to integration of q into integrating factor dy. So that means x into e raised to minus y is equal to integration of y plus 1 into e raised to minus y dy. Again, we will use integration by parts. So you can either split it or directly use. This is the first function. This is the second function. So I'll get y plus 1 e raised to minus y. And also we integrated, right? So it will be minus y. Second function or a first function integral second minus integration of this become plus e raised to minus y dy. So we got minus of y plus 1 e raised to minus y minus e raised to minus y plus c x into e raised to minus y. If you don't like e raised to minus y, then we can multiply throughout by e raised to y. So it will now look like x equals to minus of y plus 1 minus 1 plus c into e raised to y. Is it clear? We can simplify it further. You can open the minus. So we'll get x plus y. We can bring everything on the right hand side. Plus 2 is equals to c e raised to y. This is my answer. I hope it is clear. If you have any doubts in this, you can ask or we can proceed the question further. Chalo. If yes, give me a thumbs up so we'll proceed the question. Clear till here? Look at the question once more. Okay, super. Chalo. Let's see the next question on similar basis. Yeah, this is a very interesting question. Now, I need you to determine whether it is a variable like linear in y or linear in x. What I said, how to identify this? We can easily identify this by seeing कि x अकेला है कि y अकेला है. So here you can see there are multiple x बहुत बार है, x बहुत बार है, x बहुत बार है. Y you can see it is only once. That means this can be linear differential equation. So for it to be linear differential equation, let's divide by x into x minus 2. Right? So I'll get, I'm writing thoda chota because it'll take much space. It's a lengthy sum because we have to find the value of c also. Okay? So I'll get dy over dx minus 2 into x minus 1 upon x into x minus 2y is equals to x cube upon into x minus 2 upon x into x minus 2. This will get cancelled. So this is my q and this with negative sign is my p. So what is integrating factor? It will be e raised to integration of p dx. So I'll take minus outside, 2x minus 2 upon x into x minus 2 dx. Correct? After this, we can use partial fraction or we can replicate. See, I'm doing something smart. I'll write it as x minus 2 plus x. Correct? Upon x into x minus 2 dx. Now we'll split it. So I'll get minus integration 1 upon x plus 1 upon x minus 2 dx. I hope you got it. If you use partial fraction, still you will get the same thing, but I directly saw this, so I can write the numerator as this. It is fast. So I'll get e raised to minus, what is this? This is ln x plus ln x minus 2. And if you add these, you'll get e raised to minus ln x into x minus 2. So we can get the minus up. So I'll get e raised to ln 1 upon, it will become reciprocal x into x minus 2, and by property of log, this will be equal to 1 upon x into x minus 2. So finally, we got integrating factor. Correct? I hope we have not made a mistake somewhere. Let's see. So my answer will be y into integrating factor is equal to integration of q was x square, into integrating factor x minus 2 dx. So here 1x will get cancelled. So I'll be left with upper x. So I'll do x minus 2 plus 2 upon x minus 2 dx. Correct? And then again we'll split. So I'll get integration of 1 plus 2 upon x minus 2 dx. So I'll get x plus 2 ln x minus 2 plus c. And here it was y upon x into x minus 2. This is my answer. Now I want you all to do one thing. Key, substitute these values y equal to 9 and x equal to 3 and get me the value of c. C equals to, come on. Substitute these values. In the first step it is look the derivative of denominator and numerator, maybe simple step. X square minus 2x. Yeah, superb. Very good. You can do like that also. You'll get the same thing. Right? We did many steps here. Oh, it is better method actually. Very good. So what is Devan saying is that this we can basically expand the numerator, denominator 2x minus 2 upon x square minus 2x. Right? So this is basically what format? F dash of x upon f of x. Right? Yeah. So if it is f dash of x upon f of x, so it is will be ln of f of x. What is denominator? X square minus 2x. This is x square minus 2x. So we'll save time and we'll save 2-3 steps here. It's no need to write these steps. Very good. चलो c का वैल्यू 0 आ रहा है. Okay. C is 0. If c is 0, then I don't need to write c. It is 0. So this is my answer. Correct? I am not checking c. Or should I check? 5 की जगह पे 9. 9 upon 3 into 1. So 3 is equals to 3. 3 3 gone. ln 1 हाँ 0 आ रहा है. C is 0. Superb. All good till here? Should we move on to the next question? Okay. चलो. let's look at this question. Again, to see if it is a linear in x or linear in y, check whether x is single or y is single. Got it? So here, see there are multiple y terms. 1 plus y square, tan inverse of y. But x is only once, which is x. So this means this is basically the other format, dx upon dy wala. So I'll convert it into dx upon dy. What I'll get? Dx upon dy, right? So I'll get tan inverse of y upon 1 plus y square minus x upon 1 plus y square, right? So I can rearrange this and write dx over dy plus x 1 upon 1 plus y square is equals to tan inverse of y upon 1 plus y square. This is p and this is q. So my integrating factor will be e raised to integration of p dy. So what is integration of this? It is e raised to tan inverse of y. And now what will be my solution? You got a solution? X into integrating factor e raised to tan inverse of y, tan inverse of y is equal to integration of q tan inverse of y upon 1 plus y square into tan inverse of y dy. Sorry, e raised to tan inverse है ना? हाँ. Into e raised to tan inverse of y. What can we do here? We'll put tan inverse of y equals to t. So 1 upon 1 plus y square dy will go to dt. So my integral will become integration of t into e raised to t dt. What is the answer here? It is t e raised to t minus e raised to t plus c. So I think we got our answer. We just need to resubstitute t. T was tan inverse of y. So my final answer will be x into e raised to tan inverse of y is equals to. We can take e raised to t common into tan inverse of y minus 1 plus c. Is the question clear? See once again the question. And if it is clear, give me a thumbs up so we can move on to the next one. Yes. Okay, very good. Let's see the next question. This is important, substitution. Like, I hope this is basic substitution, right? You must know this. Now, let's talk about which topic? Linear equation reducible to linear. So, equation reducible to linear is a general type where one of the specific type, like equation reducible to linear के अंदर आता है Bernoulli's equation. So what is Bernoulli's equation? Bernoulli's equation is nothing but this form. Here we just got y raised to the power n. So if we don't want y raised to the power n, we'll divide by y raised to the power n. So if we divide, do you see the format? It is dy by dx plus py equals to q. Was our linear d ka format? Instead of q, we have qi raised to the power n. So we'll divide with y raised to the power n. So I'll get this. Now, an interesting thing to note, we'll substitute this p के साथ जो है ना, remember very thing, we will not learn the Bernoulli's equation, we'll use our common sense. See, every time here, if there will be a function of y, we'll just divide by y, so we'll get this type of equation. And after that, we'll put this, the function of y which is with p as t. So if we put this as t, this whole thing will become dt by dx. How it will become dt by dx? See, as I said, acha, they have used v, it's fine, you can use v or t. So if we differentiate, then I'll get like this. Now I can take n minus 1 on this side. So I'll get like this. So that means I can replace this with this and I'll replace this with this. So my Bernoulli equation will now become this. I'll replace this with this. Now this is a variable separate, linear differential equation. You can see dy over dx plus p. This whole is new p. Y is equals to q. Instead of y, our new variable is v because we substituted v in place of y. I hope it is clear. So now once the equation reduces to linear, we'll use the same procedure. Which procedure? This is p, this is q, integrating factor and solution. And in the last step, we need to resubstitute v. I hope it is clear. Don't learn this. We just learn the process. What we'll do? Agar we have something of function of y with q, we'll divide that and then we'll substitute and get the answer. Let's see, as we discussed, and can be solved. Let's see a question, this one. Now, you don't need to panic because, as you can see, the format was dy by dx plus py equals to q. But here, in place of q, we have y square. And we don't need y square, so we'll divide with y square. If I divide with y square, I'll get 1 upon y square dy over dx. Here y and y will get cancelled, so I'll get 1 upon xy is equals to 1 upon x square. What was the second step? Second step was to substitute. What will substitute? See, whatever y is left, we'll substitute that as t. We'll use t. V generally we don't use. So we'll use 1 by y equals to t. Now, if I differentiate with respect to x, why with respect to x? Because I want dy by dx. This means differentiate with respect to x. So what is 1 upon y ka derivative? Minus 1 upon y square dy by dx is equals to dt by dx. So if minus was not here, I can easily write minus here. So with these two substitutions, my equation will now become linear. How? See, instead of this, we'll put minus dt by dx. 1 by y की जगह पे t, so I'll get plus t by x is equals to 1 upon x square. We don't need minus, we'll multiply throughout by minus, so I'll get dt by dx minus 1 upon x into t is equals to minus 1 upon x square. So now instead of y, you see instead of y, we have t. That is the only difference here. This is a linear equation. We'll solve it as we have solved all the others. So I don't think we need to solve this further, but still we need practice. I also need practice. You also need much more practice. So I think we'll solve this, right? We'll solve it together. Chalo. So खाली y की जगह पे t है, तो all the process remains the same. खाली replace y with t. So this is my p and this is my q. So integrating factor will be e raised to integration of p dx. Y की जगह पे t रखना है, जिधर y है उधर. So I'll get e raised to minus ln x. Minus ऊपर जाएगा, so I'll get e raised to ln 1 upon x. ln by property of log, I'll get 1 upon x. So my solution will be t into integrating factor is equals to integration of q minus 1 upon x square into integrating factor 1 upon x dx. So this is basically t by x is equals to minus integration of I can write it as x raised to minus 3 dx. So that means minus x raised to minus 2 upon minus 2 plus c, t by x. I can cross multiply x, right? So I'll get t is equals to minus x raised to minus 1, minus minus will get cancelled, upon 2 plus cx. Let's resubstitute the value of t. What was t? 1 by y. So I'll get 1 by y is equals to 1 upon 2x plus cx. If you want to take LCM, you can obviously take LCM and simplify. I don't have space left, therefore I am not simplifying. Got it? Is it clear till here? These are Bernoulli's equation. They are very simple to identify. We can easily do it. If it's clear, we'll move on to the next question. Chalo. All good? Yes or no? So you want to see this? See once more? Yes, sir. Very good. Now, in the next question, you will tell me, what do I need to do to reduce it into Bernoulli's variable separable? Chalo. So we have options also here. The answers. See, we'll always have to divide by y term. We will always have to divide by y terms. So just look at what are the y terms. This and this. So either we need to divide with y or we'll need to divide by y cube. If you're not sure which one to divide, just check both and see which one of it's adjusting. According to me, I think we should divide by y cube, right? X cube, y cube, y cube. We should divide by y cube. See, first let us write into the acha format. That means I'll get dy by dx is equals to x y minus y cube e raised to minus x square. If I divide by y cube, I get 1 upon y cube dy over dx. इसको मैं लेफ्ट में लाऊं क्या? हाँ. So it will be minus x upon y square is equals to minus e raised to minus x square. Right? I divided by y cube and adjusted simultaneously. So now you can see which one to put t. हाँ, y cube, सुपर. x के साथ जो है उसको t रखना है. कौन है x के साथ? minus 1 by y square. So if I put minus 1 by y square equals to t, differentiate with respect to x. Please remember. So it will be derivative, na? So this is y raised to minus 2. So minus minus will get plus 2 upon y cube dy over dx is equals to dt by dx. I'll get. Check this once. Y raised to minus 2 ka derivative. Minus 2 y raised to minus 3. So that means 1 upon y cube dy over dx is equals to 1 by 2 dt by dx. Now substitute these two here. My equation will now reduce to linear, right? I'll get 1 by 2 dt over dx plus x t is equals to minus e raised to minus x square. So we have to multiply with 2. So I'll do it here only. dt by dx, 2 and 2. Correct? Now it is a linear. This is p and this is q. Integrating factor will be e raised to integration of 2x dx. That means e raised to x square. And my solution will be t into e raised to x square is equal to integration of q minus 2 e raised to minus x square into e raised to x square dx. You can see these both will get added and I'll get e raised to the power 0, which is 1. So finally, I'll got minus 2 integration of dx, which is minus 2x plus c. Just substitute t की जगह पे t क्या था -1 by y square. So minus e raised to x square by y square. Right? We can cross multiply here easily. So I'll get, पहले तो minus को हटा दो. So if I change the minus, line ही हट गया. minus c dash हो जाएगा ये. So I'll get e raised to x square is equals to 2xy square plus c dash y square. Got it? Is it clear? If you are solving yourself, please check it. And if I have made any mistake, you think Acha, done na? Okay, okay. See it one more time. Swati is not replying. Are you understanding? Or is some network issue and all? Chalo. We'll look at the last sum. We'll end the session. So we'll now be left with the last part. If you know, we were talking about exact differential, right? Yes, sir. Understood. Okay. So we were talking about, before moving on to last sum, let me show you what we'll do tomorrow, Tuesday. We will be doing exact differential. I had introduced you the exact differential. I hope you remember. We'll do some questions there and the applications. Application means word problems basically. We can solve word problems or real life problems by using differential equation. So those two are remaining. We'll cover that in the next class, which is tomorrow. And I hope you know tomorrow will be over with differential equation. And from the next class, means next class after tomorrow, means next to next class from today, we'll be starting with vectors. We'll be taking 13 to 14 lectures on vectors. So please like go through or try to attend all the lectures. So we'll complete the vectors in flow. Or let's see the last. This is a very simple, I think. We don't need to divide by anything, right? I don't think we need to divide with anything. It is already present. X के साथ जो है उसको t मान लो. इसको मैं t मान लूंगा. खत्म. It is a very simple question. Please start, and if you are done, give me a thumbs up, then we'll stop. Okay? Let me see. We also have the options. We also have next question. If you feel like we can do. Yeah. So यहाँ पे simply e raised to y equals to t. So e raised to y dy by dx is equals to dt by dx. My equation will become dt by dx plus 2 by x into t is equals to sine x. This is p, right? And this is q. This is pq. Integrating factor will be, I think, x square, right? Answer will be t into x square is equals to integration of x square sine x dx. So we have to use here product rule, UV rule of integration. But I think we'll have to use it 2 times, right? Correct, na? We have to use it 2 times. I hope you know the shortcut for UV rule. When such questions comes, algebraic raised to the power n. So we'll get basically x square sine x, sorry, x square cos x plus, नहीं माइनस आएगा, minus 2x cos x का derivative sin x plus 2 sin x plus c and t की जगह p raised to I, so e raised to I into x square. This will be my answer. Completed. अरे इतना जल्दी हो गया? शाबाश. चलो. Then we have time. We'll do one more. I hope you know the extended UV rule, which I applied in the last sum, right? Should I write it here? I'll write on the top. If we get integration of u into v dx, and out of u and v we have u as algebraic, means x raised to the power n types, then we can use the extended. You learn this in engineering first year itself. We don't have this in portion, but I think we should use this in entrance exam. So we basically write u integration of v, and we differentiate u and then integrate v. So u dash into again integrate v, and sorry, it is alternate plus minus minus plus u double dash and then again integrate v, and it will go on. Now one of the times, if it is x square, last sum x square था ना, this will be x square, this will be 2x, this will be 2, और फिर 2 के बाद सब 0 ही बचेगा. x square का डेरिवेटिव 2x, 2x का डेरिवेटिव 2, 2 का डेरिवेटिव 0, so that means we have to stop here itself in the last question. And sin x को इंटीग्रेट करना था, तो इंटीग्रेशन ऑफ sin x was cos x minus cos x, then minus cos x का इंटीग्रेशन minus sin x, again integrate, so it will be like flipping sin cos बस. तो इससे क्या एक ही लाइन में आंसर आ जाता है. ठीक है, लेट्स सी दिस. यहाँ पे किसे डिवाइड करना है? इधर पाई स्क्वायर है, राइट, और x से भी करना पड़ेगा ना. वी डोंट नीड x हियर, राइट. सो डिवाइड बाय x y square. So I'll get 1 by y square dy over dx plus 1 upon xy is equals to ln x upon x. So अभी x के साथ जो है उसको t, that means 1 by y को t. So minus 1 by y square dy by dx will be dt by dx. डायरेक्ट लिख रहा हूँ, माइनस dt by dx plus t by x is equals to ln x upon x. We can change the sign or rearrange it. So I'll get dt by dx minus 1 by x into t is equals to minus ln x upon x. So this is p, this is q. So I think integrating factor will be 1 by x. लॉग का प्रॉपर्टी यूज करके हो जाएगा आई थिंक. So my answer will be t into 1 by x is equals to integration of minus ln x upon x into 1 by x dx. Right? We can put ln x को t here and integrate, or you can directly use the UV rule by parts here itself. And lastly, resubstitute t. So don't solve this further if you understood it. We have solved many questions here. We'll end the session here, and as I told you, tomorrow we'll be doing exact differential and application. That means word problems. ठीक है? Oh, completed. Super. चलो. We'll see you tomorrow. Bye bye. Take care, everyone. Tata. Sir, you are from which JNV? I am from JNV, Hassan. You are from Hyderabad, right? Hyderabad region. Yeah. Your vacation are starting soon, but I hope you attend the lecture. JNV Krishna. Okay. These are the ठीक है, बाय बाय एवरीवन। बाय 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 बेटा।